Hello again. As you work with FPGAs and mixed analog and digital electronics, you're going to run into the problem of noise getting into your system. There are many sources of noise, but I'm going to show you one of the big ones, and I'm going to show you what you can do about it. So right now I'm showing you a 1 kilohertz sine wave being generated by the Go board and a digital analog converter, and the 1 kilohertz sine wave is being displayed on both oscilloscopes. What I'm going to do now is make things a little more challenging. I want to reduce the amplitude to 10 millivolts, and so now it's not visible until I increase the scale here on both oscilloscopes. Now on the digital oscilloscope, what we're seeing is noise, but this is not the noise that I'm interested in. It turns out that this particular noise you're seeing is from within the oscilloscope itself. It's still there even if I unplug the cable to it. On the other hand, looking at the analog oscilloscope, there are hints that there's something going on here. I see a little bit of noise riding on top of the wave, and this is real noise. If I unplug the cable, it'll still, you can see that the trace is clean without any input. So it's not an artifact coming from the oscilloscope itself. So there's something going on, but we're not quite sure what it is yet. What I've done is hook up the audio amplifier so that we can hear what is coming out of the FPGA and D to A converter. Now, I don't know if you can hear the noise over the signal, the high-pitched tone, but let's turn the volume of the tone down. So let's do that. And let's turn the volume up on the audio amplifier. And I think you can hear that. Now, an important clue as to where this is coming from happens when I move the mouse around. Or if I start compiling. So what's happening is that the noise is coming from the computer's power supply, because right now the computer power supply is making the FPGA board go. I've got the USB cable, which is used to program. The USB cable is going this way. It's used to program the FPGA, but it also is the power source for the FPGA. So if we can stop the noise from coming down the power lines on the USB, we've solved the problem. So now the problem is solved. If I turn up the volume here, we can hear the signal clearly. There's no noise. Let's turn this volume down and see what I've done. So right now I've got a different USB cable which comes out to here, and then the USB cable goes to this breadboard, and on the breadboard there is a small power supply. So the signals for programming the FPGA board are still getting to the FPGA board. It turned out that the data signals were on the white and green wires, and so I just continue the white and green wires straight to the FPGA board. But the power was on the bread wire. So what I did is, you see here, the red wire disconnected. I'm not using the power from the computer. Instead, the power is coming from this battery. It's 9 volts, and this thing wants 5 volts. So the 9 volts is turned into 5 volts by this little voltage regulator, and from the voltage regulator you're going to the red and black wires, which then go to the FPGA board. So now we have a satisfyingly clean signal coming from our FPGA board. Some cautions. When you make this sort of power supply, you've got to be careful. Make sure before you hook things up that you really are sending 5 volts this way. If you send 9 volts to the FPGA board, you'll break it. Similarly, make sure that you're not sending power back to the computer. That'll break your computer. So just be really careful before you commit. Okay, thank you.